In November 1980, a 14-inch drill bit triggered a mechanical failure that drained an entire lake in a matter of hours. Before that moment, Lake Peigneur in Louisiana was a quiet freshwater fishing spot. It was shallow, with an average depth of just 10 feet, surrounded by cypress trees and swampy terrain. On the lake's surface sat an industrial operation owned by Texaco. The company had towed a massive offshore rig into position to explore the depths below the water. The crew was tasked with driving a steel drill through the mud to search for oil deposits trapped deep in the Earth's crust. The rig operators viewed the lake as a simple staging ground. They focused exclusively on their deep Earth targets, unaware of the industrial infrastructure already occupying the space beneath them. Directly beneath the lakebed, the Diamond Crystal Salt Company operated a massive underground mine. The facility consisted of giant caverns carved into a solid salt dome. Miners left raw salt pillars to support the earth and water above, creating a vertical overlap of two industries. Lacking cross-referenced maps and blinded by a triangulation error, the surface rig drilled directly toward the mine's upper shaft. This was a guaranteed collision, caused by two industries pushing into the same vertical plane without knowing the other was there. On November 20th, the crew miscalculated their position on the lake, setting the disaster in motion. At 1,200 feet deep, the drill bit pierced the ceiling of the active salt mine. At first, the rig crew only noticed their drill was stuck and they lost fluid pressure. They assumed it was a routine mechanical issue. Below the lakebed, the reaction was immediate. Miners heard a loud pop as water flooded in. Instantly, the 14-inch hole acted as a high-pressure nozzle, forcing the entire lake to begin draining into the mine. The disaster started with that single small puncture, quietly ending both operations. The physical collapse of the entire salt mine was driven by a simple chemical reaction. Fresh water aggressively dissolves raw salt. Rushing lake water rapidly eroded the salt around the puncture, growing the hole to the size of a house. This floodwater dissolved the massive support pillars holding up the ceiling. Without those columns, the mine collapsed and the lakebed sank. The sinking lakebed created a massive whirlpool that could be seen for miles. It swallowed the entire drilling rig, 11 massive supply barges, and a commercial tugboat. One measurement mistake created a feedback loop, using the lake's own weight to dissolve and crush the mine from the inside out. The underground caverns were so large that the 10-foot deep lake was completely drained into the mine. The vacuum created by the collapse pulled the Delcamber Canal backward, reversing its flow from the Gulf of Mexico. This forced saltwater back inland to create a temporary 164-foot waterfall where the lake used to be. The disaster destroyed 65 acres of the surrounding coastline, pulling roads, trees, and power lines into the mud. Despite the scale of the destruction, every one of the 50 miners and the entire rig crew followed emergency protocols and escaped without injury. The incredible suction of the collapsed underground mine was powerful enough to physically pull the Louisiana coastline backward. This was an institutional failure. Two companies operated within a single vertical space, but failed to cross-check their maps or account for the other's presence. The coastline remains scarred today, with trees and buildings left submerged by the rising water. The rush of water from the Gulf changed Lake Peigneur from a 10-foot freshwater system into a deep saltwater basin, shifting the local ecosystem from inland fish to marine life. Days after the event, 9 of the 11 sunken barges popped back up to the surface, floating in the new, deeper saltwater lake. Lake Peigneur remains a case study in systemic disconnect, where one uncoordinated measurement turned a shallow pond into a 200-foot saltwater hole.